Hello and welcome. My name is Andre and I'm your host for the Student Tech Talk today. Together we will have some exclusive insights behind the scenes here at Siemens. I will take you with me on a little tour through our office and we will have some interesting conversations with some of our experts. There's also a chat button on the top right corner of your screen, so feel free to ask your questions. We will answer them in the end of the stream in a little Q&A session. Currently, we count over 600 registrations for this Tech Talk, which is amazing. So thank you very much for tuning in today. As I said, my name is Andre. I'm a working student here at Siemens Technology. I studied technical journalism and technical PR in Nuremberg, and I'm about to start my master's in communication and media engineering. I started working for Siemens a couple years ago in the technical marketing, and then I moved last year to the technology department. Here we have a lot of freedom to develop our ideas and share it with our coworkers, which is always fun. I mainly support in communication and creative tasks like creating websites, flyers, guides. I also support with topics like the tapas board or the Sushi challenge. So we always have new projects we can work on. It basically never gets boring here. But enough about me. I would say, let's see who's here to talk and start our little tour. And therefore, I'm going to switch to my mobile device and take you with me. Let's go. All right, here we go again. So normally Michael would sit here, but unfortunately he had a corona incident and has to stay at home. But he can still be with us from his home office. So hello, Michael, and welcome to our stream.
Hi, Andre. How are you?
I'm good. First of all, how are you?
So I'm fine. So I'm negative. That's the first positive thing. I did 2 tests already. And yeah, I guess it's better to stay at home so I can work from here. So yeah, let's do it.
That's really good. So you would not mind telling us a little bit about you and your work?
Yeah. I tell you a little bit about my past, what I did, and how I came to Siemens. So more or less the journey started. I had now a look on the calendar, and it's really long ago. It's around 20 years. So that was the start in my professional work education. These days as a mechatronic, and therefore I learned a lot about electronics and mechanics and stuff like that. And after that, I had the chance to work on a quality department for a company, and it was really interesting because 1 year I learned a lot. I learned a lot about electronics, mechanical parts, how they interact, what can be faulty on them, what is working, what is not working. And after that, work as a professional, I had the chance to work on a, let's call it customer service after sales department. And it was in a call center, to be honest. So that sounds not so good like the thing before, but I had to work there. And it's only one experience I want to share outside with the outside guys there. It's, they had a machine there and you have to put this machine, unplug the cable, remove the insides, the water and stuff like that. And then you have to put it on the back, 90 degrees, and then you have to throw 3 times on the top of this device. And then you have to put with your hand inside this device, and then you have to remove the dust and the dirt and stuff like that. And exactly that thing I did, I guess, I don't know, 40 times one day. And this was exactly the day to say to me, Michael, what do you want to do with your life? So maybe go back to school, make your A-level, and make something out of your life. And that was more or less the kickstart to do that. So then I didn't had A-levels these days. So that was then the starting point to do that in a Berufsoberschule, it's called in Germany. And I did there the A-levels, and back from my professional work education, I know what current or current and automation is a little bit about, and that was the day to say, okay, now I want to go in a way to learn about how this stuff is produced, how energy is made, and stuff like that. And this was the reason to choose a bachelor in the direction to do renewable energies, in the direction to go a little bit where comes energy from. But always keep in mind that automation background, that automation thing in a direction, how can I automate such a big plant, the machines in there, what's going on with PLC, control, automation, all that stuff you need to run such a system. And it was really interesting, and I started, I guess, in the semester 5 to work for Siemens as a working student these days. And therefore, my job was to have a technical evaluation about a monorail system. Yeah, you think monorail from, I don't know, it's known from The Simpsons. There's one series. It's not about that. It's about manufacturing cars. It's about in smaller industries. It's on the top of a building in the construction site. And this monorail is going through the whole manufacturing plant. And within that thing, for example, inside such a big monorail is a car, like a Tesla or other cars are produced in such plants. And they are completed part by part. And Siemens components are driving that monorail systems. They automate them and stuff like that. And my job was first as a working student to have a look what technical parts can be used, what is inside, how is this done. The first thing was a little bit more theoretical, but then I did my bachelor thesis in this topic. So I started as a working student and then did my bachelor thesis there. It was really interesting to have a look on different technology, how they interact, what we can use out of our portfolio and stuff like that. So that was the first touching point with Siemens. And they said, hey, Michael, do you want to start at Siemens? And I said, yeah, I did this professional work education. And yeah, I did then the A-level and then study. Yeah, why not do a master? Okay, then no, Siemens, I don't want to start in you and to do their job. I said then, okay, let's do a master. And I decided to do a little bit more not so theoretical, more practical master in the direction of applied research. And these days I did a lot in the lab. I did a lot with my hands, programming, wiring, stuff like that, soldering. And this master was about then more in the direction of informatics, more electrotechnics, and it goes a little bit in this direction, electrical machines, inverters, automation, PLCs. And on the other hand side, in the renewable energies like photovoltaic, wind power, battery systems, stuff like that. And within that master, I had then as well my degree. And I said then, okay, Michael, what do you want to do now? So do you want to go to a company and work there? I said, yeah, maybe stay 1 year there and have a look if I want to do a PhD. And I said, okay, after that year, if I have clear criteria to start with a PhD in the direction of renewables and stuff like that, I will do it. And I decided, to be honest, after that year to don't do it. Then I had a good opportunity to Siemens and start there as a product manager. As a product manager for digital services. And we started, or the idea in the startup environment was, these guys these days are really crazy. They want to use big machines for creating concrete or paper plants. They want to use big drives to be a flexible load in the energy grid. The idea was these days to say, okay, if there is too much energy pushed by wind or solar or others inside the energy grid, then switch on these drives. They are really big and they consume a lot of energy. And on the other hand side, if too less energy is in the grid, then shut them down. And this was a thing, we had the idea, we did some proof of concept, but it was not finally done. But it was really interesting to learn with these guys. And after that, I had a position as well as a product manager to do energy monitoring systems and digital businesses in the direction, how efficient can be a plant, how can such a big facility like before within my bachelor thesis be energy efficient and stuff like that. After a couple of years, some guys asked me, hey, Michael, are we building an energy storage system? Do you want to participate? And I said, yeah, I want to build the energy system since, I guess, the last 5 years. And that was the reason to do in a startup approach as well, again, an energy storage system. So we started from scratch and we developed it more or less by self. We used a lot of components from the market already there, like a startup is doing it. But we had a product in the end of the day after 2 years. And it was really, really crazy this time. And I guess another guys in the call will explain you a little bit what we did so far and stuff like that. And at the moment, I'm working on an IoT topic. So the idea is to enable IoT for brown and greenfield, but I will tell you later on about that. So Andre, that's my part. So I guess you know Sonia already. She has a lot of interesting insights about 3D printing in her life. If you want, you can go to her.
All right. Thank you very much, Michael, for your insights. From cleaning coffee machines to creating whole power grids, everything is possible. Thank you again, Michael. So let's see what Sonia is doing. She usually does a lot with 3D printers, what is really cool. So let's see if she is in the workshop. I also want to remind you about the Q&A in the end of the stream. So feel free to ask your questions already. Hi, Sonia. How are you? So we are in the workshop. As you see, we have some 3D printers here.
Okay, so wait a second. I'm going to stop the printer so you can understand me properly. Okay? So I have to wear the mask because of the corona restrictions, and I hope that you can understand me in a second properly. I will do my best.
I guess it will be fine. So Sonia, would you mind telling us a little bit about you and your work here?
Yeah, of course, Andre. So I'm Sonia Cordobes. I am 30 years old and I come originally from Spain. So I have been always passionate about technology, and that's why I decided to study after high school and engineering in industrial design. After doing some Erasmus exchange, I moved back to Madrid and I studied a master in production engineering. While doing it, I had the chance to make an internship in a sensor factory of Bosch in Madrid also. And finally, while doing my master thesis, I got my first real job in a small company that did precision metal machining for the aerospace sector. I stayed there for around 2 years, and after 2 years, I decided to quit my job, leave everything in Spain, and move into Germany. The main reason for that was personal, because my boyfriend is German, but I also wanted to get a better level of German and explore new opportunities for my career here in Germany. The second one, I got it, and the first one, I'm still working on it. So after a couple of weeks living in Germany, I saw in LinkedIn a nice job opportunity at Siemens, and I decided to apply for it. I was not really sure about my chances, first because, as I said, I couldn't barely speak German, and second because my profile was really into mechanical engineering and not so much, I didn't know so much about electrical engineering. My first surprise when I came to the interview was that it was not the typical interview where I sit in front of some human resources people just selling myself to them. It was more a nice talk in a round table with some experts and my future managers about what was my expectations, what was their projects. They told me the location here, the different labs, and so on. Luckily for me, after a couple of weeks, I got the answer that I was getting the position. That's how I became an industrial designer at the technology department of Siemens. Now you can be thinking, okay, that's really cool, but what is an industrial designer doing and how that is involved into the development of electronic parts? So basically, you might know that every electronic component that you have at home has such a plastic enclosure. So the main functionality of these enclosures are to protect the electronics from the outside, but also to protect the people from the electronics. And it's something that the customers assume that is there. And it doesn't look really fancy or anything really complicated, but there is a lot of engineering inside it. So the first thing is that you have to consider is what is the application of this electronics. So maybe if the application is in the outdoor, you have to take care that no water or dust is coming inside the electronics, or if maybe the device is placed in a very warm place, you have to take care that it's not getting too hot, and you have to allow the air coming into and to cool the device, or maybe even think about some kind of metal heatsink to dissipate the heat in the device. Furthermore, you have to think that the device indeed is easy to use. So, for example, you cannot have a button here in the backside because the customer could never reach it. And also, last but not least, you have to care that it's somehow aesthetical and that is attractive for the customer. Yeah, and as I said before, I'm working in the pre-development department. That means that I'm not caring about the final product status, but somehow on an intermediate step. And there, to save resources is really important because we are working with cutting-edge technology that should go to the market as soon as possible. And when I'm talking about resources, I'm mainly talking about time. So that's why I have to get involved in the very early stages of the development of every project when the PCB is just a drawing in a paper or a two-dimensional model in the computer. And my work is basically to translate that two-dimensional model into a 3D model and explain my colleagues of the electronic development where to put the different devices, how to make the layout so it's thermally stable. And whenever we have defined all that stuff, we go for the prototyping phase. So, and that's why this kind of technology, what I have behind, 3D printing, is essential for us because just by coming from my office to here in 2 minutes, I can start printing such a mock-up and have it in my hands in few hours. So we can validate some design elements, and that is something that is helping in our daily work a lot. So yeah, I hope that you get more or less an overview on what my work is. Now I'm trying to explore further opportunities for my career, and I'm trying to get into a little bit into project management and processes. For that, I get a lot of support from my managers, like, for example, Michael, that is always helping me to share his know-how, inviting me to meetings to know how he is doing. And of course, I'm getting some trainings from the Siemens experts. Apart from that, since last year, I'm part of the Nachwuchskreis Erlangen Mitte, that it's basically a talent network inside Siemens that put some young careers of Siemens together in a team. And the idea is that we can therefore increase our network, but also do some really cool technical projects. And what is more important, some social projects for the community here in Erlangen. So there I could see that the variety of Siemens profiles is quite high. And that was also a really cool thing to see.
All right. Thank you very much for your insight, Sonia. As you hear, Siemens is doing a lot for his young professionals in early careers. And Sonia, one more question. What do you like the most working here for Siemens?
Yeah, that's a really good question, Andre. So I would say that my favorite thing to work at Siemens are my colleagues. We work in a really multicultural and multidisciplinary team and environment, and that is allowing me to meet a lot of people from all around the world, to travel also to different locations, and to learn many things from my co-workers. Yeah, I have learned in these years, for example, how to program an Arduino or even how to solder a component into a PCB. That was something that was known by me, and maybe if I would work in a mechanical engineering department, I will never find out. And talking about those nice colleagues, always willing to help, I think that Stefan is in the lab nearby. Maybe he can give you some more insights about our work.
All right. Thank you very much, Sonia.
You,
sounds great. So then let's see what Stefan is doing. As Sonia told us, he is probably in the lab, do some experiments. Let's see if he's here. Hello. How are you?
Yeah, I'm great.
I will take a sit.
Exactly.
Stefan,
So,
how is it going?
yeah, kind of great, I would say. Right now I'm adapting our framework to the tougher sport. So some colleagues from abroad can integrate or can use our development workflow with MATLAB and Simulink a little bit more easy. And I'm fixing some bugs. So
You're fixing some bugs?
I'm fixing some bugs, yes. But let's start over with myself. So I'm Stefan, I'm 26 years old, and I'm a mechatronics engineer, or I'm working here as a power electronics engineer, but I studied mechatronics and started with it back in 2014 here in Erlangen at FAU. And I didn't exactly know what to study, so I was struggling between mechanical engineering, electrical, and also the computer science. And then I thought, yeah, why not mechatronics? Because it covers all three of these topics. And yeah, it was a good thing because I never thought I would end up in the power electronics field. That was something I didn't have in my mind at the beginning. But so during my bachelor then in the fifth semester, I wanted to gain my first industrial experiences and looked out for jobs. So I found this vacation here at Siemens, and vacancy again, and then applied to this job, and it was a quite interesting offer because it said I'm gonna work at a startup-like environment with a few hardware and software experts. So I thought, maybe I could really contribute to something here, and this is exactly how it went. So I'm really happy to have this job, or also having the time here as a working student, and it probably also was kind of the best thing that could have happened because also my mentor Jenny. I had lots of freedom to do, but she always let me do the things I thought it would be best or it would be work out good, and usually things worked out good and then everything was fine, and if not, we looked at it together and then we found the issues and then went on with a good result at the end. So I had lots of different tasks. So I started with some kind of Python web application. Also there I have an open vacancy right now. If you're interested in Python and web development, have a look at my LinkedIn or wherever I've shared this. But whatever, I started with this and this was my first touching point with Python. So now I'm using it quite frequently for evaluations of measurements results and automation of my daily tasks and whatnot. So it was a really good experience to start with this. And then of course I worked in the labs with measurements and initial setups of prototypes, and then reported them back to the engineer. And also, I had my own opinion about if something failed, and then wrote down and made some analytics. I can't remember everything because it was really so much. But what I also did was high frequency measurements, characterization of electric components with network analyzers, or it's called the Bode 100 device, which plots here the Bode plot of whatever it's connected to. This is very important if you're working with GAN devices because you need to know the frequency response up to a few megahertz in the end if you want, for example, to build a proper filter for your device, so it passes the EMI tests. And this is also why I focused a little bit in the direction of high frequency in the end with my studies, which is quite uncommon for the direction of power electronics. Also, what I had to do, I was given the chance to develop my own prototypes for some measurement setups, where I had, for example, to automate some testing. So we built, but this was not completely my work, we built some inline tester for the tapas boards. You may have heard of them already, because we manufactured them within the company in Berlin, and I also was there as a supervisor somehow for having a look at the results, if everything works out fine. And then we developed a tester, an inline tester, which was a huge box, and we would do lots of things differently, but it worked out, and with some graphical user interface, and it was a really interesting experience. Then lots of other projects I was a part of, and then I finished my bachelor and stayed here at STI, and went on with my master. And then we had the finished tapas boards, the first version, and did the tapas challenge. I was also part of this team, selecting the ideas of the participants and kind of choosing who to send the boards to and which ideas would be sponsored by us. And after the challenge, I somehow became responsible for the tapas board, and this was also quite interesting because then we made a new version of the tapas board, and there's also a new website coming up soon, so if you stay tuned here, I will also share information about this with content on also how to get your hands on one of these boards. So they're limited, but we still have a few, and would like to sponsor some other great ideas. And back to where I was starting. So we had to certify to make a EMI and safety certifications for the tapas boards. So for the CE confirmation declaration. So we can send the boards out to Europe, and this was also some new domain for a research and development group here, and a very interesting task I had to, and also I built up an interesting network back then. Then after some more projects, I got offered the part-time job here at STI with my bachelor, so I could finish my master degree and then just continue working here, which I gladly accepted because it's a really cool team. So we have different topics here, and we sometimes build up products from scratch. So we have an idea, and we did this twice already. So maybe Michael mentioned the June Light, where I also took part in some of the initial hardware setups. So let me see. Okay, so what I wanted to tell you about something, maybe you know the tapas board already, which is what I'm promoting and I'm responsible for. So it is a small gallium nitride inverter that has the benefits of being very flexible because you have DSP on which you can program freely. And so you can decide what software is running on the device, and you can use it for your individual setup, for your individual project. Like electric skateboard, you may have seen this, or we build up a Class D audio amplifier with the tapas board. So you have your motor inverter making some good music for you during lunch break. So yeah, just stay tuned for this, and I will show some additional information on the website.
All right, thank you very much, Stefan. As you heard, he is an absolute expert. And Stefan, can you tell us also, because we are here in the lab, and how you handle the situation between home office and coming to the lab? How do you cope with that?
Yeah, actually, I really like being in the office because it is I have more space than at home, but of course, the other colleagues who don't need to be in the lab are working from home, and so do I if I don't have to make any measurements or experiments. But since they are at home, I can come here and do my measurements without having too much contact to other people. So this is not a big deal. And for example, if you're developing software, like I guess you are next switching to Elias, then you can have a look again and how things can work out as well.
All right, sounds very good. And as Stefan mentioned, I want to take you to a colleague's home office because that's more the rule than the exception at the moment. Elias is a software developer, and he will give us a little deep dive about his work here. So hello, Elias, and welcome to our stream.
Hi, Andre. Hi, Stefan. Thanks for the nice pass. So as you said, I'm Elias. I'm 33 years old. I'm a software developer. And originally I come from Greece. I started at Siemens like 5 years ago. So going a little bit further back, I studied in the Aristotle University of Thessaloniki. I studied electrical engineering, and I had a specialization in computer architecture. That's where I also got involved in a robotics team in the university, and we did quite well. So we built an autonomous robotic platform that was used for space exploration and victim identification. in, let's say, post-apocalyptic or disastrous environments. And this platform was taking part in the RoboCup 2012 and achieving like second place. And that attracted the attention of Continental Automotive in Nuremberg. So they recruited my whole team. So me and my classmates, let's say, came here to Nuremberg to be trained and then sent back to Thessaloniki to open a new branch over there. That plan failed after a while, after a few months, but we still had the option to remain and work here for Continental. And that's pretty much how I started my professional career after my studies. At Continental, we were developing control units for transmission, for automatic transmission. And that was an interesting job to start with. There are many things to consider when you're developing software for automotive applications. Safety is a big factor. So I was working in the safety team as well. And it was nice. It was eye-opening for me as a student to become a professional on this topic. But it was rigid and restrictive. I was still young and motivated to develop and write more software, integrate open source libraries, stuff like that. But you didn't have the chance to do that in the automotive domain. At least that was my experience. So yeah, after a few years, like 4 years at Continental, I thought, yeah, I want to do something more, So that's when I found an opening at Siemens technology department, and I made an interview. I had 2 interviews actually. So the first one was over the phone. I got asked some technical questions, and we did some kind of background discussion. Then I was invited for an in-place interview. And then there was a big brainstorming, and yeah, we were discussing and thinking about solutions during the interview. It was really fun experience. I never had such an interview before. And yeah, so at the end, after I left my interview, I think it was like 1 day or 2 days later, I had the job, and I was happy to start. STI, so software defined environment and inverter. That is still the name of the team. And I was lucky to be in a multicultural environment, interdisciplinary. So we had electrical engineers, mechanical engineers, software developers from all the ranges of software development, like embedded, mobile, cloud. And it was like an open maker space, as I said. And that was exactly the place I wanted to be back then. So among many things, we had to use Linux as well, which was also fostering development and stuff like that. In this job, I got involved with 2 topics mainly, like many topics, but the main focus was 2 topics. So we wanted to develop an application software framework for, let's say, constrained embedded devices, which would enable them to connect to the cloud, right? And that was the main tasks. That framework is called Cactus, and it is actually a software framework that enables connection to the clouds, and that was mainly my focus back then. And also we wanted some kind of a pilot product for this software framework. So that's what Michael mentioned before. That was the idea of a domestic energy storage system back then that we started developing from scratch. It was merely a PCB or an Arduino. And in the course of several years, it became a real product out there in the market. Yeah, so like this is how it would look like at the end. And yeah, I don't know, it looked like this when it started. So you can imagine that this is this is a maquette, right? This is not a real product. The real product would be this big, like a wardrobe. But anyway, you can imagine that this is a fulfilling experience, right? And having to develop this from a prototype, like on a raster or a breadboard, to a burning PCB that wasn't even working in the beginning, and to become a real product, that was definitely fulfilling. And yeah, I can only be thankful about this. So we had some nice times with the colleagues in the lab during this time. What I wanted to say more is that it's not those 2 things mainly only that I focus. So during the course of these years, we had to create and get involved in different side projects. So apart from apart from that, I develop software for like commercial grade PCB to smaller, edge devices, to so more like a hobby project kind of platform. It's like a self-balancing bot. Yeah, it's not perfectly working, so I will not demonstrate right now, but it could be working. Yeah, and then also we have this kind of board which we are working right now. This is like a general purpose, let's say, module that has different hardware interfaces and can connect to the cloud. So you can program it for a variety of applications. And this is the so-called Sushi board that we want to do the Sushi challenge with. And that's something that I'm currently heavily involved inside. It involves software development in the embedded level, but we can also reuse the Cactus framework that we already have, and some ideas from the cloud backend. So this is actually taking off right now. But maybe Michael is more suitable to give you more details about this one. So that would be a good pass for him right now.
All right. Thank you, Elias, and also for showcasing on some components. I do have one more question about you, is how Siemens is handling the home office situation, since you are in the home office right now.
Yeah, right. That's a good question. We didn't talk about that enough. I think I couldn't be more happy about the way that the company is handling the situation. So right now we have to stay at home as much as possible. But the company is very open to acquiring equipment, for example, so like you can even get your own monitor from the office to your house if you don't have a big one, or if you want two or stuff like that. Even a chair, you could even ask for a anatomic chair to take it with you at home. And I think also after the pandemic, the home office idea is not going to die, because there's a new regulation, or let's say a new guideline that as when it's possible, it will be encouraged to stay at home office, like maybe 3 days a week or something like that, which is also very meaningful in my opinion. So overall, I'm very satisfied with how the company is handling the home office situation right now.
All right.
Yeah.
Sounds great, Elias. Thank you again.
Bye.
For your time and your insights. As you see, I'm back in the office. I'm in one of our meeting rooms, and Michael will join us now from his home lab. And hi, Michael again. And he will telling us a little bit more about Sushi, how it started, and of course the Sushi challenge, right, Michael?
Yes. So I guess it's lunchtime, and maybe we did another dish, as you get already. So we did several years ago these tapas board. So if you put in Google tapas and Siemens, you will find the Git page to that thing. So it's the thing Stefan told us. And what he not said, or I didn't get it, was that out of that thing we made a product like that. It's a small yellow gray box from Siemens, but it's a product. And within these tapas stuff, we did the basement for the product. And at the moment, as Elias said already, we are doing work on the Sushi, as you see on my screen. And I'm able to work from home on the topics. So I guess we have the possibility to nearly, there's no speed down. It's a little bit, yes, if you can do not go in the lab and measure stuff, but we can really work on the topics. And we will build up a proof of concept in the size like that to have a smart unit for software-defined hardware interfacing, it's called, the Sushi. And we want to happily invite guys of you who are interested in to participate in our Open Innovation Challenge. We will do the same like we did in the tapas some years ago. And if there is interesting, we will come up in a few months with the launch of these activities and want to invite you to that. So that's it from my side. So if you have no questions to us, so we are all now here having a look in the chat, what you have written. And we will answer them. So
thank you very much, Michael. I'm back at my laptop, and as Michael already said, we're going to start with our Q&A session, where we will answer some of your questions. So if you want to know more about our experts, the work here, or specific topics, feel free to ask anything. We do already have some questions from you. The first question would be to Sonia and Elias. How did you manage the language barrier in the beginning, since you're not a native speaker? Maybe, Sonia, you can start answering that.
Yeah, that is a really good question, Andre. Yeah, so I can say that it was maybe even too easy because everybody is really willing to help us and to talk with us in English. And as I said, we are working in a really multicultural environment where there are more foreigners. We also have a team in Portugal, so we use English a lot, and that was a little bit problematic in the beginning because we were not forced to talk in German. But we also got some paid courses from Siemens in the first weeks. So yeah, now I can say a few words at least.
Yeah.
All right. Thank you. Elias, maybe.
Yeah, I have the same impression. So it was a very smooth transition. Multicultural environment. So English was also there as an option. But we also had a convention with Michael where we would practice the other languages. He would try to talk more in English to me, and I would respond in German. And then you would have a discussion where two languages would be active on the same time. So yeah, in general, a very open and friendly environment. And also the German courses is a good thing if you want to improve your German as well.
Yeah,
it's also offered.
So I guess maybe something to add. So it's I guess really interesting to get these intercultural experience. So we are in the technology. We have as well another team part which is in Portugal. They're working, I guess, around 15 people for us, and we have to talk to them only English. So you have days here as a German guy, you speak the whole day English. So it's not only for the guys who are coming in, so it's as well for the German guys that they have to speak in English. So, but it's okay.
All right. Yeah, thank you for answering that. Another question would be probably to you, Michael. When does the Sushi Challenge starting?
So we are now in preparation. So you have to do a lot of regularities if you want to bring out such a close to product device. For example, do an CE certification, do electromagnetic tests and stuff like that. So we will finish our plans is that we are in the direction of May, June. We have the 1,000 parts available, and then we will start our challenge. And 500 we will spend for internal and 500 for external. So it's the plan at the moment, but maybe Corona can change plans. We will see.
All right. Thank you. Another question would be to Stefan. Do you have an open position for a working student job?
Actually, yes, I do. I have an open position for the Python web application I mentioned before, which I started developing as a working student, and now we need to adapt a few things to do a new deployment and to have to use it a little bit more. And so I need somebody with Python, Flask, web development, and also maybe Amazon AWS or Microsoft Azure knowledge and experience.
All right, perfect. Elias, a question for you. What was the most fun project you have worked on so far?
Fun project, well, particularly funny. I would say it's not the project I worked on, but it was a skateboard from Stefan. I tried it, so that was the funniest one. So yeah, actually I worked on because I wrote it for tests a couple of times. Yeah, it's partially my project as well. Yeah, that was the funniest one, to be honest. Electrical skateboard. Yeah, definitely this one.
You can see it in the background here. So.
Yeah, that's one, exactly.
Yeah, it's driven by the tapas board. So we had the idea to do it as a showcase, and it's why not build up an electric skateboard? So.
Okay, another question to you, Michael. Do you have projects based on long-range wide area networks?
So the LoRa topic at the moment we are really interested in. From our point of view, it depends on the technology. So you have to have a look what base stations are used, if there is a grid available and stuff like that. But it's a topic we're having a look. So as you know, we are in technology. That means we are more or less the pre-development department of Siemens. That means we need to have a look on new technologies, stuff like that? The answer is yes, we are interested in the technology, but at the moment we don't have a concrete project. But we are searching for them if they're out there.
All right. Thank you, Michael. Another question for me. How did I get a working student position here at Siemens? Basically, I just applied. I Googled some positions where I can work, just applied general over the job portal. And then I got invited to a talk, and now I'm here. So that's how I landed here. And another question would be to Elias. Do you have some dedicated time to learn new coding frameworks or learn new architectures, or are you going to do it by yourself?
Well, that's another good one. Actually, I have been willing to make an artificial intelligence course online for the past years. And actually I asked Michael, hey, can I get like, 10% of my time? And he actually said yes. So I did that on an online platform. And actually, over the course of 3 months, I got the certification, let's say, in artificial intelligence, which was like, I'm thankful for that. So yeah, you do get the time that you need for stuff like that. Definitely.
All right.
Yeah.
Someone is interested, Michael, where you did your master degree.
In Nuremberg. So I did go outside before the masters for let's call it external semester in Austria. It's another country, but it's the same language. And then I did end up in Nuremberg on the University of Applied Research and did it there.
Okay. A question to Michael or Stefan. Do you address maintenance in general IoT devices, life cycles management, or especially in regards to the security aspect? Maybe Stefan, you could.
I would pass this to Michael. So
okay.
I guess this is.
So you have to make sure that if you have a look on such devices, you have some requirements in a direction, small, not too expensive, but you have to take care that security is given. Otherwise, you will be lost outside in the market. If you have an incident, it's a thing which is, I guess, on the basement of such a device. Authentication, encryption, safe connection up to the cloud and stuff like that. You need to do that. Sure.
All right. I do have another question for Sonia. Sonia, did you get the knowledge for the 3D printing and all the stuff by yourself, or did you learn it here?
No, I actually learned it almost everything at Siemens. Of course, I had some pre-knowledge, but it was not really deep into that technology because I have no 3D printer at home. And basically my task in the first years was to build up the entire tool chain for the mechanical development and also to build up the mechanical lab. So we have one here that I showed, and we have another upstairs with a laser cutter and so on. And I really dedicate a lot of time in the beginning of my work here just for building up the know-how.
All right. Another one for you, Sonia, when we talk about the printers, aside from enclosures, do you work on something else with the printers?
Yes, so the main purpose of the printers is to print out mock-ups for our products, but we also use it for giving support to the team. So maybe sometimes they need, a holder for a PCB or some special tooling for the lab, and we are also using it for that.
All right. Another one for you, Michael. Do you have experience with ESP32 or 8266 platforms? If you have, do you think what do you think of these microcontrollers, and could they also be used in an industrial environment?
I like them. So have a look on Elias, how he's smiling. So the Espresso framework, it's a really, really great microcontroller. So these guys out there did a really good job, especially on the 32 variant. To be honest, it's a really powerful thing. So you have a lot of cores inside. You have a lot of possibilities in the direction of GPIOs, storage, how it is designed and stuff like that. It's an amazing hardware, to be honest. And yeah, so I know that's especially the thing you are asking for, more or less. So we have them, and we are using them to do really quick prototypes, to be honest. But if we have to go into products from a Siemens point of view, we need to have some different other requirements. Sometimes these chips cannot fulfill. That's sometimes a problem. It depends really on the project. But if you want to start with electronics, and if you want to start with Learn from your side, these frameworks are great. So you can do a lot with them. You can have a great experience, and there are a lot of examples out there. So try them out and work and progress on with them. So it's really good frameworks, both.
All right. I hope that answers the question. And Michael, again to you, how do you work on aesthetics and ergonomics after the development of a raw product?
I did not get the question. So the ergonomics on the hardware and stuff like that. So I think we having a look. Maybe hopefully I'm answering the question correct. We're having a look what is needed out there by guys who installing cables, stuff like that. But from another point of view, you see the gray box. And another thing is you see UIs, for example, like that in Android, iOS, or the web. And therefore, we have experts who are doing the user experience and stuff like that. So they know which flow is needed, for example, to bring such a device online. If you think about stuff you're having at home, like your vacuum cleaner or different other things which are now connected, it's really easy to bring them online by your own, by an app or stuff like that, scanning only a QR code. The device is then mapped to your account online, and you can reach it in the cloud. And that stuff we have in our activities as well, that you can bring the devices, the stuff really easy online. And for that, a user journey, user experience, testing with a dedicated test group and stuff is done. That it is from an ergonomic point of view given to bring these devices online and fulfill their requirements.
Yeah, also we try to apply the agile methodology, so we do a lot of iterations and we try the things quite early in the state, so we avoid the mistakes and we make a lot of trials with it.
Yeah, and that's especially really nice to have Sonia in the team. That if you're saying to her, Sonia, we need that and that in the design, she has it the next day, and then we can have a look and say, okay, that's not so nice. Do it other way around, or that's it. And that's really good to within these fast, rapid prototyping approach.
All right. Sonia, someone asked, what kind of 3D printers do you use? FDM, SLS?
Yeah, so we are using FDM printers. So there are the filament ones that are fuse modeling. And basically before we also had some stereolithography ones, but it was a little bit messy because now what we have here is an office environment and we are not allowed to use so much chemicals or so. So that's why we focus in the filament ones. And whenever we want something a little bit more fancy, we go for an external company. But the first mock-ups are always here, so we are not depending on some third party company that has to deliver or something like that.
Yeah, so I don't know if you can get that from the quality, but it's, for example, a mock-up Sonia printed out, and it's totally feasible for our needs, I guess.
Yeah.
All right. A question to Elias or Michael. Do you address bidirectional near-field communication similar to RFID technology? if not, is there anyone in your section to maybe get in contact with?
So in our section, not. So we have products in the direction of industrial and near field communication. So Siemens is offering sensor tags and stuff like that, which, for example, is used in automotive manufacturing to track monorail system, as I told in the beginning, or other systems which are used in the industry. So there are dedicated products. If you search RFID and Siemens, I guess you will find them. If not, give me a mail or a message in LinkedIn, then I will give you the right contact.
All right, thank you, Michael. Question to Elias: which programming languages do you use the most commonly?
Right, it's a good one. So mostly, currently, we develop our software framework in modern C++. But as I said, it's an interdisciplinary team also in terms of software development, right? So there are people doing the cloud stuff, so backend, they do like Python, and we have developers on the mobile, they do more Java. We also use Python a lot for testing and automation and factory processes and stuff like that, simulations. So there's no limit, like any programming language. So if you also want to use like Haskell or Lisp and you have a good idea, we can also open our minds with this. It's no problem. But mostly C++, modern C++, I would say. This is where Cactus, our software framework, is built on.
All right. And also, do you use neural networks in your team? And if yes, which tasks?
So maybe Stefan, you can answer.
I would say the same.
Maybe I can say a little bit about this. So we're using neural networks in our team. So neural networks can be applied to lots of different problems, let's say. So on the one hand, we're doing predictions on, I would say, on some temperatures, for example, in the inverters, to predict and to maybe find some better operating points. Also, we are trying to use them to optimize control parameters and this kind of stuff. So it's lots of usage in the direction of optimization with neural networks. It's a kind of a new topic, especially for me, because I'm more in the hardware section from the electronics. So I'm starting to dive a little bit into this direction right now.
So maybe one thing to add from my side, especially on that topic, machine learning. We have a master's thesis at the moment, and that colleague is working to bring that together with our embedded devices, inverters, and stuff like that. So the answer is yes, we are working on, and it's an interesting topic. And from our point of view, it's really interesting for the future. What you can predict in a direction of predictive maintenance, make our controls better, stuff like that.
Yeah. All right. And one last question to all of you. Could you explain more about how a mechanical engineer plays a part in developing something which is more based off electronics and software background?
Well, as I explained in the workshop, I get involved in the very beginning of the talks with the electronic developers, and we discuss things like, what are our restrictions in size, what are our ambient conditions that are really defined in the product, and I'm caring a lot also about thermal management of the device, so it's working fine without getting too warm. And also the placing of the different components in the PCB is essential, and that's why I iterate a lot with the electronic developers while doing the layouts. And then, we translate that in 3D models. And also the graphical part is really important. Whenever we try to sell a product, you need to have good renders of what you want to build. And then it's much easier for people to understand what you want to develop.
Yeah. And then on the other hand side, you have normally to manufacture it all of the time if you're building up something. And that's a big part where these guys are playing a essential role. And
All right, thank you. I think that wraps it up. That was our little Q&A session. We are at the end at our Tech Talk. Thanks to all the experts and, of course, the participants in our live stream. It was really fun to talk. I hope you tune in on the next Tech Talk. You all will get an email after this Tech Talk where you can get some feedback. So feel free to do that. And yeah, thank you again for participating. See you next time.
Thank you.
Bye-bye.
Thank you. Thank you.
Bye-bye.
Goodbye.
Bye-bye.